I've heard that Tokyo U is quite the prestigious academy that's quite hard to get into. You see that all the time in different animes, right? Guys like, oh, I gotta study really hard to get into Tokyo U. So I think I'm decently smart and knowledgeable, so I have here entrance exam questions for Tokyo U to see, well, can I do decently on them? Maybe I don't. I don't know. Let's take a look here. Here is first question out of 3. They are all mathematics because it said so on the website. No other purpose. All right, let's see. Let R3, R to the third. It's got a weird font for R, so it's probably just R3. Or, I don't know. I'll just keep reading, okay? Don't make assumptions. Let R3 be the set of the three-dimensional real column vectors, and R3 by 3 be the set of the 3 by 3 real matrices. I'm going to pretend like I have any idea what that means. Let N1, N2, N3, I don't know what that symbol means. What, E, like, pitchfork? Let N1, N2, and N3 murder R3 with a pitchfork out of, I don't know, riots? Be linearly independent unit length vectors, and N4, who could single-handedly kill R3, okay. Be a unit length vector not parallel to N1, N2, or N3. Let A and B be square matrices defined as... What in the world does this thing mean? I might have went over that thing once in a class, but I have no clue what that means. What? Okay. So maybe... No, I wouldn't say it's hard. It's just, so far, I have no idea what these things mean. It is not hard, but more so a knowledge check. And maybe it is hard, but I need to pass the knowledge check first. Here, xt and small xt, there's no x. So what? I see a t, but I don't see a, what? Denote the transpose of a matrix X. Okay, what? And a vector X, respectively. Answer the following questions. Oh, delightful. I think now's a good time to mention I can't use a calculator. It is not allowed. Sorry, no Desmos for me. No graphing today. Alright. Let me get out my pen. Just, I don't know, make a new layer. Why is that so big? Do I have like a writing pen? It's just a normal pencil. I'll just go here. 7. That'll work well enough. So first, we need to find the condition for N4 such that the rank of A is 3. What? Yeah, I'm getting hard knowledge checked here. Okay. So rank of A. We know A is here, right? That is A. N4. The only N4 is here. Okay, we know all of these are in a row, right? I'm totally going to be guessing on these. I have no clue what I'm looking at. So I'm going to have to make some very hard guesses. But we have all these. They're all in a row, right? I'm seeing that. And they're all in this grid, which I'm assuming is the matrix. So I'm seeing here N1, N2, R3. I don't know what R3 is. That just the size of the grid? Because it is 3. 1, 2. That's not how you write 2, 3, right? So I'm going to assume maybe R3 is going to be the size of this grid. There's a high chance I've already gotten this entirely wrong. So, great. Linearly independent unit link vectors. That is a complicated way of saying they're They're numbers. I'm going to assume. I don't know. In 4 is not parallel to into 3 or 4. Could this be one of those weird ways of making a graph? Like you have this, and then boom, 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 boom. And it's like actual parallelism. Like, do. And then that one's like over here somewhere. I'm not overly sure. Such that the rank of A is 3. What does it mean by rank? Like, I can't just... It's not like A equals 3. It says the rank of A. Does that mean A equals 3? Do all of these have to... Well, no, because they don't mean anything when they're above each other, right? Still, what does the T mean? I know in 1 is defining number 1, right? Number 2. What does the T mean? I see a T like here, x equals T there. No, the transpose of matrix X, it could just be talking about an actual graph, right? It really could be. I just peeked a glimpse at number 2. 3-dimensional Euclidean space. Oh, my favorite. Okay. Okay, find the condition for N4 such that the rank of A is 3. I still don't know what the rank of A means, so that's going to be a hard one to figure out. If I don't know the condition for answering the question successfully, then how in the world am I going to know what I'm finding? The rank of A. And of course, I can't look anything up, because that's not allowed on the test. Well, hey, this kind of looks like it's saying Mini. Or Nini. I don't... No, it is saying Nini. Or Ninit. Because there's a T. I don't know. I'm getting sidetracked. Luckily, I didn't find a time limit, so I'm not putting myself to that. Great. Find the condition for indoor such that the rank for A is 3. Rank. So I'm thinking, right? If I have this, rank, I think, is going to be here. So X marks the spot, right? And then you can have these wherever, right? But rank, I'm just thinking X or maybe Y. Because I'm seeing here 3-dimensional non-Euclidean space. This tells me this is a graph. This right here is a graph. It is going to be a graph. I don't know what type of graph it is. I'm going to assume it really is just this type of graph, right? But then I have to figure out what to do with that. What does it mean for condition of N4 such that the rank of A is 3? Is this one of those where all of these have to equal up to the same amount? And then, I don't know what N4 is going to be doing. Right? But if I do something like, let's say, N1 equals 12, right? We literally don't have a Y. That's a bit of a problem, unless we're talking the minus sign there, so you are going to be like, if you're 12, then you're going to be 9, so it's at 12, 9, maybe. I don't know, a decent guess. I can do 12, 9, which means the next one would have to be at 9, 6, in order to be 3 for A, which then, I mean, it keeps following that trend, though, right? Which means this N4 has to be 3, if I keep doing that like that. But that could be any sort of number, right? This could be 9, and then this is going to be 3, right? Assuming we keep following that tradition, and then, I mean, we got a triangle, right? Or more accurately, just a linear line going down. Which makes me think that's not it either. So it's maybe not a graph. But we do have N1, N2, N3, and 4. Then that makes unit link vector not parallel. What does this mean? What do you mean? Unit length vector, not parallel. Parallel being this way. So I'd be like, do. I've mentioned this. But the, okay. This is okay. We're fine. It's only the first question. And there's, oh goodness. Okay, I gotta speed this up. Condition for N4 such that the rank of A equals 3. If we do N4 is a unit link not parallel to N1, 2, or 3, which could mean that these are all different sizes there. But parallel, having to be this way, means that it is required for them to have 2 numbers, right? And as I'm aware, N1, the 1 there is just going to be, what is it? The notifier, right? It could be N1 or it could be X, meaning this one's Y or Z and then A. I don't know. Doesn't matter. They're just numbers. Number 1, number 2, number 3, number 4, right? Which I guess we mean we need T in the power symbol, right? And the only thing that we have here with T is this B, which has what in the world is going on here? Is this an epsilon thingy? Literally, I'm pretty sure when we went over this, it had to go in the calculator. That's how they taught it. Calculators are not allowed. How do I never even bothered figuring out what this meant. Hmm. But there is an interesting tidbit I'm noticing here, right? It has an I equals 1 declaration. And sure, that's a little, they might be like 12 pixels there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 pixels in the eye, but that is an eye. I can see that. There's only one possibility, and it's an eye. And that's an interesting declaration to make, given that unless it's being dumb, which it probably is being dumb, that this eye is kind of declaring all the other eyes, which is here and there, which also doesn't make sense because this eye with the 1 should be here, so we have a double declaration, and therefore we're going to error. Still, what does the 4 on top mean? What does B even mean? We don't have a B yet, so therefore we shouldn't even use B, right? That A and B square matrices defined as that. So then why A and B? Which clearly there's some meaning to that I don't know. It's like determinate. Determinate meaning. And as long as I don't know what that means, then I couldn't tell you. Note the transpose, respectively, answering the following questions. Yeah, it's a hard knowledge check. I'll flag this one. I'll get back to it later. Okay. Maybe the next one is easier. I say, as we were talking about Euclidean space. In the three-dimensional Euclidean space R3, consider four planes. I, okay. 2 big eyes and a little eye equals X pitchfork R3, which I forgot what that one meant. I should know that. Could be or. Usually that's used as or, so could be. NTI X minus D to the I equals 0. D to the I is a real number. I'd hope so. I don't need any fake numbers here, all right? And I equals 1, 2, 3, or 4. Now, here's another question. Are we assuming that the question's add on? In which case, I, 1, 2, 3, or 4 could be these I, 1, 2, 3, 4s. I doubt it. I think it's I think it's just a different question. It's just using the same thing here. So, sad. It might give me something. Though we already know I equals 1. Double declaration. Satisfy the following conditions. A, the rank of A is 3. Yes, so it wants you to figure out the rank of A first. The rank of A, which I'm still assuming is going to be the x-axis. Considering A is, A, B. Get back there. You little flag. A, B, so it'd be A, comma, B. Meaning, yes, this is going to be our x. So we're going to have x equals 3. Meaning these don't all have to equal up. Because we need specifically n equals 4 to make this equal 3. And because we have this all in a row, it could be anything that makes it 3. So u or n3 is required to be bigger than n4 by exactly 3. I don't know what this means, though. When I see this squiggle, that doesn't tell me anything. I see n3 is bigger than n4 by 3. Simple, easy. What is this? I know it's not parallel. And these are linearly independent unit-link variables. So they could be basically anywhere. They could be here, 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 there. Or they could be there, 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 or here. We just know the last one is not parallel. In which case, my original assumption is probably the best I'm going to get until I can figure out how I can solve this. Well, solve is a strong term here, given what in the world does this mean? I equals 1 at the bottom. There's a 4 on top. There's that. We're multiplying it a lot. Now I'll make another assumption here. It wouldn't make a lot of sense, right? And no calculator quiz for this to be a random decimal sort of thing, like a 6.2, or I guess 3241 as one of your answers, right? I'm going to assume it's most likely to be 6, especially when we have a equals 3, 3 being, well, 3. It's not 3.14159, whatever. And therefore, I can assume this doesn't do too much. Because it's not going to make it overly dramatic in terms of decimal placement. Additionally, these all have to be whole numbers. And they all have to be whole numbers because we have to multiply. And T. They all have T's, though. Why are there T's? Because there's the big one and the little one, but there's no big or little declaration. So I don't know what a big X and a little x defines. Hmm. Okay, so back to here. After the rant. The little quick rant. It wasn't that long. Rank of A is 3. Number 2. Why in the world do we have an omega? I thought we said we're talking about real numbers here. This is an omega. Omegas are not real numbers. Unless this is a different omega that I know, in which case I don't know this one. So that one is equal to x. That maybe the x t stuff are there. So what in the world does a t mean? Xt r3 nitx. It's the same thing here. Than that. Hold on just a second. That format's a little interesting. I see here that it declares x. It has what happens with x, and then what I equals. That's a while statement. It's just a while statement right there. So it'd be while this is greater than 0, and then I is equal to 1, 2, 3, 4. It's not an empty set. Oh, great. So now it's there's something in there. I'd already assumed that, given that this is a problem. And 3, there exists a sphere. C, are we C? C is a bigger C omega, to which I 1, 2, 3 are tangent. That's like an angle, right? Huh? The position vector of the center of C, being our circle, is represented by a to the minus 1 u using vector u. Express u using di with I 1, 2, 3, 4. I is always going to be 1, 2, 3, 4, right? So anything with this is going to be I 1, 2, 3, 4. Does I have to stay the same? That's a good question. Given I have no clue, does it have to stay the same throughout? Additionally, what's the question? What I equals? It just says, consider these things. I guess we're expressing u using di. So u, where is u shown? U is shown here. That's it. Okay, di is shown like all of them shown here and here. That's it. So the circle is representing the u, and the di is representing the other things. Now I can do while statements. Just need to know what in the world the declaration is. I have no idea what the pitchfork means. Why are we killing R3? Unless R3 is this thing. It's just showing that it's part of the group. X is part of the group, which is here. It's part of that group. In which case, we follow along with this over to here, right? So, and that makes sense with ni, because we only go up to 4 here, right? So then it's just in 1 x minus di is greater than that. But in which case, that assumes we already solved this, right? So, in which case, I need to get as close to a solve as I can without knowing this. And if I can do that, then I think I'd prove pretty good that I am just fully knowledge checked. That's a big if, though. This is Tokyo U, and I've already been at this for 23 minutes. And I'm only on the second question. Out of the 3 problems, each with 5. So the position vector, yeah. A, -1. I don't know what A means. There's no other A. Okay. So floor planes, double I. Double I used anywhere. Used here, but that doesn't make sense because it doesn't say anything else about it. Okay, so X is part of that, meaning, let's scroll up here. It's just minus DI. DI is a real number. We do not have any other mention of DI, do we? No. So DI can be whatever, as long as it is above 0, or it equals 0, I'm sorry, and fits with these. Okay. So therefore, it's still kind of at a loss. So DI can equal 1, 2, 3, 4. I is still going to be there, so because it has a declaration, and I hope this is correct, it's going to be the same, right? So equals 1, 2, 3, and 4, meaning it is true for all of these. Which means we can already go and assume that n to the I times the, we'll make it a bigger X, I don't know, just star it, there you go, is going to be equal to di, right? That makes sense. Because it has to, equal 0 at the end. Does that follow here? Is less than or equal to 0. It does follow the this second one, yes. It does follow that. Meaning whatever in I is going to be in I equals di, so, and that's only going to be up to 1, 2, 3, or 4, equaling up to there, which is fine. So we know that we don't know what x is, do we? I guess transpose a matrix. Don't have. We're not dealing with that right now. We don't need to deal with the transpose or whatever. Probably. It really doesn't matter that much. Satisfies three conditions. Rank A is 3. Which I think just kind of this and this is enough to solve that. However, I still need to figure out what x is. Because I have not solved this top part. We can kind of figure it out at a time if we know what either n or x is. So I'll see if there's any more in here. This right here is pretty fine, honestly. Really doesn't matter that much. It's not an empty set. Yeah, go ahead. Here's a sphere. Using di, yeah. I is always 1, 2, 3, 4. Position vector of the center of x is represented by this u part of the set. Express u using di. A minus 1. A to the negative 1 power? I forget what negative 1 power does. Theoretically, it just makes it negative. Because what else would it do? So, I guess that's what we're doing. Negative A, position vector, the center of the circle is, okay. So the center of the circle is a negative A times U. A, that doesn't, rank of A is 3. A there. So A very much matters because this is a circle now. Okay. We got a circle in a 3D space. Forgot about the 3D part. I don't think that matters though. So A is this. The rank of A is 3. But didn't we already determine that that means this is equal to 3 because we're talking about a graph? Because that really wouldn't make sense. Because that would be way too easy. It's just 3. 3 to the negative, and then U, and then U is whatever di is, right? Meaning we could figure that out, probably. Well, that would just be like a no-go if it is 3. Just don't know what this means to make it all, or to figure out the specific of the 3. But then again, that really doesn't give me much, does it? Because I can assume this is 3. And so if it is 3, then this equals what? What does it equal, right? What does u equal? Because it's di, which is equal to n times x. And until we figure out what one of those things is, we got nothing. come back to that in a bit. We're making progress with other question. Show that B is a definite or positive definite symmetric matrix. Which is just this. So does that mean we're even carrying like B, A and B square matrices? So therefore, B probably doesn't matter in the top two questions, does it? I don't need to know B to solve this. Meaning what? Because these could be anything. Assuming I have it correct in what it is. Because there's no like symbol or anything to show this top one to this side one. So they'd all have to equal up to 3 somehow. You still don't know what n equals, because it could be whatever. T could be who knows what, because it doesn't say. And so if we're not caring about B, then what? Here's a what is it wanting from me? Find the condition for N4 such that the rank of A is 3. I mean, looking at this, it could be whatever, right? You know, you do this, and then it's this. Square matrices, well, you can't do a square with only 2, right? Because that would just be x, y, and then you could have, well, you have 3, but then this is not a square, that's a triangle. So then what does it mean by square matrix? I know a square matrix where it's like x, and then y, and then z, and then a, and these are all like square because you can cross them out, right? It's like an actual square, right? This is not an actual square. So what in the world does it mean by a square matrix? Because nothing about this says square to me. It's talking about parallel. And then they're all by themselves. And then N4 in the group. So that's the only way I got for that. It's going to be not parallel to 1, 2, or 3. So I can only assume that my original assumption is correct-ish. But then it says find the condition, which means it has to be only one option, right? Such that the rank of A is 3. Let's solve a question first. Let's go to 3. Show that B is a positive, definite, symmetric matrix. Well, I'll make this easy for myself. I don't know what in the world this is. Therefore, I cannot solve this question. I do not know what that means. I don't see how it could be a matrix. Therefore, no. Question solved. Okay. We've made progress. Set the point P from which the sum of squared distances to four planes x are 3, and then it's the same d1 stuff. D real number is minimized. Distance 4 planes is minimized. Okay. The position vector of P is represented by B, -1, V using vector. V is a part of the group. Express V using Ni and Di. And I is, of course, 1, 2, 3, or 4. Sum of square distances, but they're minimized. Square distances to 4 planes. 4 planes? Hold on. 4 planes? When a 3 matrix thing? When we have that, and then you can add a z-axis, and that's 3 planes? So where's the 4th one? Are we talking like airport planes? You got like a Boeing? 4 Boeings? We gotta figure out how close they can get to each other without crashing? Consider the point P from which the sum of squared distances to 4 planes is minimized. This is really a knowledge check here, isn't it? Because I don't know what these things mean. I only assume that this means you're part of the group. Part of this group. R3, because the 3 means 1, 2, 3. I guess that should be this way. It makes a 3. Huh, cute. Therefore, I have no idea. Look, I'm at a loss. I'm starting to consider giving up on these. Right? Which, probably a common sentiment shared by people taking the entrance exam. I'm very confused. Just because I don't know the knowledge. I don't have it. Might as well mark that off. I don't even need it. Just taking up space on the screen. Don't need ya. So until we find out what one of these things is, which I assume Ni is the one that we find, considering that, find the condition for N4 such that rank is 3, linearly independent, linear, unit length vectors, not parallel. I mean, that still could just be the, 12, 9, 9, 6, 6, 3. You put them on a graph, it goes, what, 12, 9, then 9, 6, and then 6, 3, and that's not parallel. And they are linear. I guess linearly independent, so they can't be there. But in which case, for A to be rank 3, assuming I'm correct with my, this, that, then they have to be -3 from each other. Unless there's more to those. But that wouldn't make sense. Ugh. I still have no idea what the T means. Why is there a T there? The power of tea? Are they drinking tea? I know they like their tea there in Japan. Usually it's bitter. Just kind of what I am right now. So, maybe it's a good question. It's all just storytelling. It's foreshadowing to me or the test taker taking the test being bitter at the tea. Be funny given that that's an English joke and this is a Japanese test. Luckily, they did have a proper translation for on their website, so good for you. Clap, 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 clap. I was checking numbers, and about 36% of foreign students who apply actually get accepted. Not many people apply, unless they're good. Which apparently is not me. I'm not applying for Tokyo U. Something I just realized. Usually, as I've did before, I'll put back my 12, 9, whatever example. 6, 6, 3, right? Usually when something like this is written, they have it shown as this, to show that each of them are separate dot points. However, if you notice, this is a big line. It's shown as this. Is that just a different way to do it? I don't know. I haven't seen it like that before. It could just be a different way to do it, and it shows the exact same thing. But that doesn't make sense. Maybe it's all one big point. That doesn't really make sense. Probably just a different way to do it. And I'm overthinking this because I don't have any actual things. Is a set of 3 by 3 real matrices. R3 times 3. 3-dimensional real column vectors. 3 by 3 real matrices. So just 3 of these together, sort of thing, right? Is 3 by 3. Meaning this is a column of that. Meaning I have no idea what is the rest of them. But that's like when I was doing school, I see something like this. And it's like R 3 by 3 be the set of 3 by 3 real matrices, and we already know that it's kind of is this. So I'm like, okay, duh. It's like a duh thing. Like, of course, that's how that works. If you put 3 of them together, it makes 3 of them, right? We learned that already. And here I thought this was Tokyo U. Of course, 3 plus 3 plus 3 equals 9. Put 3 of them together, and there's 3 of them. 1 plus 1 equals 3. Let R3 be the set of 3-dimensional real column vectors. But we don't have the other ones. They could be whatever. Unless we put them together. We like put 3 of them on the side. A 3-dimensional real column vector. In which case, let me see if I can do that. So it's like, I'm here, 12, 9. But that already shows 2 of the dimensions, so... What? I can't visualize the 3-dimensional thing with points. That's not how it works. How are you supposed to do this without a calculator? I can't physically write this down. And don't give me the like, oh, you do the math and logic and stuff. No. That's not possible for something like this. Otherwise, I would have done it already. I trust my smarts in that form. In that sort of thing. Unless it's a knowledge check, which it really could be. But in which case, it kind of seems a little easy. It's just like, oh yeah, you put 3 of them together, and then you got bam, 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 and then you got like, I don't know, bam, bam, bam somewhere else, and you go there, and then it's like there, there. I guess there, right? And then you connect them all, and then there's a third one, which I guess is there, maybe. You connect, and it's still a triangle, isn't it? No, that's not a triangle. That's it's a triangle. It's a 3-dimensional triangle. Three-dimensional triangle could work. All right, okay. I'm looking here, right? It's not it's not parallel. Because we have a 3-dimensional shape, it just has to be the 4 cardinal directions. Or I guess the 6 in this case, which is that way, that way, that way, that way, and this way, and that way, right? You know, hand forward, back, side to side, up and down, right? That's how you move your hand. I go this way, this way, this way, this way, this way, and this way, right? And I'd assume all those would be considered parallel here. In which case, I need to brute force the one thing that isn't. How do I figure out all the points? Well, I just kind of did it there, didn't I? You have to flip it. Flippy flip. Flip flip. Now, if you do it like a paper, like if you were to sit I have this copy of Rune Factory 5, alright? Not 5. Rune Factory Guardians of Ozma, I'm sorry. And I put it standing up, right? And I sit it down. The only place that stays the same is the baseline, the 0 x-axis. You know, I can do the same, but for the y-axis. You know, the only thing that stays the same is that, right? Anyway, I move it, the rotation point is the only point that's going to stay the same. So therefore, unless the numbers equal up, it wouldn't be a parallel, right? You know, I do a 6, 3. Hmm. I do 6, 3, and it's going to be like this. And then I put it down, and it's going to be like that. And considering they're on different planes, right, I could draw it like this, and then, one's going to be like right here, right? Then the other's going to be like right here. So they're not going to be parallel. And the other one's going to be over here, which means they're still not parallel. And so what does it even matter? They're not going to be parallel wherever I put them. As long as it's not 0. It has to be greater than 0. So assuming it is a 3-dimensional thing, and it is a real column, and you put 3 of them together, you have a 3-dimensional shape. Then, therefore, assuming that none of the numbers equal, then N4 on its own will not be parallel to any of the other ones on their own. Meaning what? Do I just find the condition where N4 such that a rank is 3? Okay. Then I guess the right answer that I'll put down is N4 is going to be greater, that's a greater sign, than 0, and then comma, N4 is, or equals N3 minus 3. That's my answer for that one. Ta-da, unflag it. Delightful. Yay. Clap, clap, clap. Given that, we now have the value of Ni. It's whatever, okay? It can be whatever as long as it is higher than that. Okay. Which therefore means what? It's not really a value, is it? Because it's just a possible range of values. Does not look like a 3. It looks a little more like a 3. It's close enough. Not even so, that's Ni. Unless I do the weird random thing that they do sometimes, where they swap it from different sides, which could be really funny to try. Which in that case would be what? Ni, and then, which is equal to Ni plus 3. Here, I'll just put it there. Ni plus 1 minus 3. Right, and then we got the little star, and then x equals di. Now, it does have to be in there, because order operations, right? But, I mean, does that make a difference? Well, duh, of course it does. Maybe? I don't know, we can move this over to the side and just say Ni plus 1 minus 3 is equal to di times x, right? And that really doesn't actually do anything now that I'm thinking about it. Never mind. But we have this. We have this, which is a plus 3, which is a slightly different way to show it. And I told you this was dumb, because what do I do now? It has to be in parentheses. We have the order of operations. just thought of the dumbest thing. You just move this to the side. You won't have the order of operations, meaning this doesn't have to be in parentheses, meaning you would move it over to the other side. That's not how that works, though. It sadly is not. Express u using di, meaning di has a set value. Di is a real number, it says, right? Di is a real number, which means it can't be a range. We already know what? It's a something something 0. Which means I don't think this is right because it has to be real. And, range is not real. And because we only have these that make it real, then this is all wrong. I'll leave it as is. Consider the point P, blah, 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 blah. So SV, 4 planes is minimized. In which case, this would be, what, 1? Is it 1 is greater than 0? So then, yes, it would be, for simplicity's sake, and not going to, well, real random imaginary numbers like 0.0000 continuing until there's finally a 1 at the end, but there's never an end. We'll do a 1. Just simplicity. So it's going to be 1. So N4 is 1. Delightful. Di is real number, is minimized. Well, if it's 1, then we kind of can figure it out, actually. Which means what? Ni, so 1 times x. What is x? We don't really know x, do we? But it's all. What does that mean? X real number minus. And the same thing, but minus or just greater than or equal to 0. Is not an empty set. Greater than or equal to 0. But then now it's, I don't know, it's the what? So if we have it be greater than or equal to 0, then 0, but that, well, it can't be an empty set because we need it already to equal 0. So never mind, that doesn't help. So di real number is minimized. The position vector of p is represented by b negative 1 or whatever, using vector v, which is in the thing. Express v using ni di. So we're talking ni equals 1. So just a 1. It's a 1. For simplicity's sake, because that's what 4 is going to equal. Therefore, this times that equals 0. So 1 times x minus d1 equals 0. I mean, so this could be anything, really. Well, no, because we have the, well, it still could be, because we don't know what x is, and then therefore d1 applies, like what? X equals 1, 1 times 1 minus 1, so that could be d1, but that could also be 2, 2, it's 2, so it's going to equal x in this scenario. With the 4, it's going to equal x. If this is, 4 times that, it's, so di is equal to in I. Wait, really? Di equal ni? What? Because if this is... No, it can't be. Di equals Ni squared? Because then therefore... that's 1. But then that would be 16. So this is 2. No, it's just Di equals Ni times X. That's just what that equals. Di equals Ni times X. That's what we already know. Because it's written up here. Delightful. I've just gone in a circle. Not unlike what I've been drawing. All these zeros. They're all circles. What does it mean? It means it's 0. There's nothing there. So yes. That equals that. If it's going to be a 1, then it's going to be a 1, I guess. It's minimized. The distances. In which case we go with this, but subtract 2 from all of them. So just imagine it's this, but 2 subtracted. At the top. Normal thing. Yeah. The position, express V using that. Position V is the sum of squared distances. The 4 planes. 2 4 planes? We don't have 4 planes. What are you talking about? It's minimized. 1, 2, 3, 4. Are they all considered a plane? What does that mean? Why? How? Which plane is it? Does it matter? Yeah, there's 4. Of course the 4th plane is going to matter. Because I don't know where it is. It's minimized. Press V using N, I, D, I. Go there, there, there. It doesn't matter because where's the 4th one? So unless we're just considering planes as this, or planes as the straight lines that go throughout something. You know, this is a graph, these are planes, right? Do. But that doesn't make sense. So therefore, I'm going to assume it is squared. The sum of squared distances. Just, actual. In which case it is still 3. They all have to be 3 away. Except if you're going from this way. In which case you got to do Pythagorean theorem, and I don't like that. So therefore, I'm not doing it. The sum of those. Express V using Ni di. Okay. That's still P. Position P represented by B negative 1, B minus, and then times by V using vector. V is on the... Because then, there we go. I don't know what that means. What does that mean? Why are we putting a negative sign in front of this and then putting V in the array? Oh, where does it fit? Here, there, all of them? It doesn't fit in the array. Yeah. Because then again, here, allow me to express my argument a little further. We put V in the array, right? And in order to figure out what V is, or express it, we need to use Ni and Di. And these things are gotten from the array, right? Because that's what we got. This is Ni. Di is gotten from Ni. So let me draw a little chart for that. We'll do off to the side. Okay, so we start with Ni, right? And then we go over to Di. All right. And these are all in the chart. Well, this one's in the chart, and then that one's there. So we'll just do chart, right? Chart goes to Ni, right? And now it wants us to use Ni and Di to find V. Okay, so Di finds V, and V is in the chart. I've drawn a circle. you see the issue here? So if we have ni affects di, which affects v, which affects the chart, and the chart determines ni. So until we can figure out how v affects the chart, then it's cyclic. And therefore, if it's cyclic, what do we do? Now, that doesn't make any sense to me. This is a Tokyo U question. That one, it can't be, something that weird, right? So, therefore, I'm getting knowledge checked. I get this. There's something here that I've missed because I don't know what it means. Like you. Afterwards, I need to show my work to a math major or something. Alright, let Li be a straight line through a point Q, the position vector of which is xi in the array, parallel to ni. 1, 2, 3, no, 4? In the array? Okay, weird. Let Ri be the orthogonal projection of an arbitrary point R. That is so dumb. Why is it arbitrary? Hate arbitrary things in math. Because they are arbitrary. It wants me to come up with a full solution to something that is arbitrary. That's not how this works. The position vector of which is y in the array onto Li? What? Like YLI? We just send them on top of? Just send them right on there? Piggyback ride style? I didn't think they did piggyback rides at Tokyo U, but I've seen pretty weird things in anime, so it wouldn't surprise me. Position vector of Ri is represented by y minus wi yxi using a matrix wi. Okay, we got the full matrix, which is the matrix 3 times across itself to make a full 3 dimensions. The identity matrix is denoted by that. Okay. Express wi using ni and I. So essentially here, we have ni, which is parallel to xi in the array. Now, a bit of a problem here. Let's take a look at what parallel means again, right? We have this and this. These lines are parallel because they are on the same plane. That means they are on the same plane. If we have a line here, it's there. So if we're just looking at parallelism, which one of any of these dots could it be? It could be any of those dots. They are all on the same plane. Okay. Now, perhaps it's a little different because, we have the 3 sort of thing. So, right? So, therefore, in order to make it parallel, well, each eye affects each other, so they all go down, meaning it's just xi equals I plus whatever, right? Or equals ni plus whatever. Okay. Position vector of which is, all right, yeah, the position vector. We are already dealing with straight lines. So yes, I'm correct here. Li is the random straight line that goes through these points that are already random, because they can be anything, as long as it follows that format and is above 0. Let Ri be the orthogonal projection of an arbitrary point R. That I don't get. An orthogonal projection of an arbitrary point R. What does R mean? The positional point R is represented by this. Using the matrix Wi is in that. What? Where is it? Where is it positioned? You don't tell me anything. You just tell me it's in the full array. What does the full array make a difference between the short array? It's just the same thing stacked 3 times. How in the world does this work? We have y minus this times y minus that. So assume y is 2, right? y2, this is 2. Xi, who knows, right? But we have, I don't know, assume it's 1. That means this is 2, so it's w times 2 minus, or 2 minus w times 2. So it's not really impossible, kind of like how I thought it was. You know, like y minus y equals 0. Duh. But then maybe y times y equals 0, and then it's just 0. I don't know. I kind of don't know where I was heading there. It kind of made sense to me, and only me, and not to anyone else. You don't get to know what I know, okay? Not allowed. In which case, this could still be anything, right? We haven't narrowed it down. Using a matrix, this almost spells weird. The identity matrix is denoted by I there. Okay? Have we ever seen a big I? I mean, I can have some. We've seen 2 big I's there, but that is 2 big I's and it is not 1 big I. They are very particular about that in math, as I have learned from my fellow teachers. I say fellow. I'm not a teacher. If I was a teacher, this would be much easier. So therefore, express W and using NI and I. Show that WTWI equals WI. Because if this is the case, then that means I'm thinking about this all wrong, right? The only thing this could equal is 1. Because we have a WI and then whatever this T is, times the WI is equal WI. Which means, or I guess it could be 1 comma 0, right? Something like that. Because you have 1 times 1 equals 1. 0 times 0 equals 0. So it has to be this. It has to be that. Because unless this T does something really weird. In which case, what? And also, how in the world would that still change it? It's still being multiplied. Unless they changed math since I did it last. That would be dumb. It really would be. Consider a plane. E. How's the U looking? X is in the plane. A, T. There. Okay. A is also in the not plane. A is also in the array, and it is non-zero vector, and B is a real number. Okay. Let S be in the squiggle. Okay. Be the point where from which the sum of squared distances to L1, L2, and L3 is minimized, which we already figured out. Is this. This is the answer, where ni equals 1, or, well, following this chart. Be the point from which the sum is squared, distance is minimized. In which case it has to be in the middle. We're talking like that. In which case, I don't know. I don't want to do Pythagorean theorem. Because I also don't remember it, because I never had to use it, because it was always dumb. Said I never had to use it. I figured ways around it. It's easier that way. Which means, yes, I did just say it was easier to figure out my own method of doing them than to just copy whatever the teacher said via the Pythagorean method. This is why I should get into Tokyo U. Because I'll totally disregard the teacher. When in one else into or orthogonal to each other. I kind of forgot what that means. Is that just this way? Which means, I mean, that would make sense, because that would make sense, yeah. Are orthogonal to each other. Does that say at the top? No, that's just that. Are orthogonal to each other. The position vector of S is represented by... What? Why do we so many A's? I still don't know what the T means. Using a vector that express W. Using W1. You know, I think it's finally time to move on to problem 2. Alright. Maybe this will be a little easier. Okay. Okay, problem 2. Consider a function, fs, defined by the following integral for positive real numbers s. Okay. Talking function, blah, 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 defined by following integral. The Fallout 76 does this mean? What is that? What are you? It is a squiggle with an infinity sign on top. And this. Does this denote range? Because that kind of looks right. It could be any number. Why are we doing exponent here? This is an exponent. Are we exponent on exponent? Is t as minus 1 and the 1 is exponent to the minus t times dt? It's the following questions. Okay. You may answer without showing that the above integral coverages. Coverages what? What is it covering? What? Coverages. Okay, that makes me think this is just denoting the range. I'm going to get rid of it because I think it's just denoting the range. And if I'm wrong, you think I figured out what that means? Okay. So s equals 1. So therefore, t1 minus 1 exponent to the negative t plus t is a... What? Well, no, it's not negative. Unless... Because it's all going to be positive real numbers. Take a look at the range. Look at that. There's no negatives. Therefore, it is not a negative. The only negative is here. So, unless it's plus there. So 1 plus 1, t. What's t? What does t mean? We also have dt. What does that mean? We literally can't figure that out. Because we do not have them. We can solve as long as there's only one remaining. We know s. S is 1. What does the other stuff mean? dt. We know... This one of those move around again things. How? How would you move this around? It's exponents. We can't move them around. Okay. Put a pin in it. The inequality, unless that's not exponent. And that's something else. EXP. Is he getting to level 20? After fighting all those dragons and all those dungeons? Okay, exponent t is greater than t to an exponent. Okay. This is a joke, right? divided by n to the exclamation point. In factorial. At least I know what n means, right? Ha ha ha. Okay. Holds for any positive real number t and non-negative integer n. Okay. Delightful. For positive real numbers, show positive real numbers s. Range being 1 to 0. Of the following inequality. So all that is less than 1 divided by s? When, okay. Assuming s is a positive real number, which could make it even smaller, right? Meaning that every time s goes up, this goes smaller. Meaning we are working with decimals without a calculator, mind you. No calculator. So says that thing I looked up on the internet. And if it was wrong, then I didn't think people lied on the internet. So show the following inequality holds for any real number c that satisfies c is greater than 1. Meaning that it still is probably a range. I'm assuming it's going to be range t. Because it already confirms other stuff. So, but seriously, I can't solve. I can't. It doesn't give me enough info to solve. And the second order derivative of fs is expressed as find a function gts. You may answer without showing that the order of differentiation and integration can be exchanged. Okay, I wasn't going to. I'm still... How do you answer this? What are we can't solve. We don't know what these mean. They're not numbers. I don't know what a D is. I don't know what number that is. I don't know what S is. Actually, I can kind of figure out what S is, can't we? I don't know. Does this affect all of that? Which means it can be whatever it is, as long as it is within the range and is positive real number. Any way you look at it, I can't solve it without giving me more info. I could find the value of F1. It's a racing thing. Okay, F1. And when that means S, so S is 1, therefore it's there, and therefore it's a positive real number. Meaning T minus 1, which is... then it's X. We still don't know what T is. We need to know T. X. I've already seen that as exponent. It is exponent of this. So this is exponent of this, which is times this. I don't know what D is. And then since I don't know what D is, I can't figure this out. I need two of the above. I need to know what F is. I need to know what T is. Or I need to know what D is. I need two of those three, and I can solve this. There is no possible solve without knowing those. This is not a logic puzzle. If it was, we would have a little more info. Where even was I? Find the value of D defined as this. Okay. We have logs, no calculator. I'm pretty sure. Then, well, what am I even looking at? Log 2 exponent negative t dt minus this. What? Here you may use the fact that the following relation holds. It gives you help for that. It sees this is too complicated, so it gives you help. What does that even mean? The following relation holds. This. Why in the world does the solid bar have a number? Being s equals 1. Unless that means that means s equals 1, right? S equals 1. Pi is squared, which still, no calculator, divided by 6. So pi is squared divided by 6, which is roughly, I don't know, 314, 2. It's roughly a bit over 2. And I can't figure this out because I don't have a calculator for log. I could brute force it. Figure out what these things were. You're useless. It's still just a 1. That'd be 1. 1 divided by that. 2 log and times f. We don't know f. So maybe I couldn't solve this. Because we don't know f. Now f could be up here. Or is that just function? Does f mean this entire thing? Do I need to copy paste that in order to go here and to solve that? Because we know s equals 1. So do we just we copy paste here, then go back down here and see, oh hey, that all equals that. So therefore, I don't know, times d squared. I don't know. It's not how that works, and neither will it do anything for me. And even then, sure, you can logic it out a little bit. But as a rule of rules, you can't figure it out unless you got only one of those things remaining. Otherwise, it could be different. Or, well, I suppose, you could have a solid hold on what it is. Right? If your number is, I, or we'll just do x. Simplicity's sake, x, look at that. We know x is going to be greater than 4, but we also know that x is going to be less than 7. We're going to have a pretty good assumption that it's either going to be 5 or 6. All right? Is that possible here is the question. It could be, assuming I'm not getting knowledge checked. I am getting knowledge checked. I've never seen some of these things before. As such, I really don't get that. Even just looking at this, right? We'd have to knowledge it. Or not knowledge it. We'd have to logic it based on that same factoid. We also need to figure out what T means, what F is, what D is. Unless we're just talking about F being considered function, which is really dumb. Because we do this. Like, would it be different if it was T instead, for instance? It is T now. It is T1. Right? Would that make a difference? Because we already defined T here, right? All I'm doing is changing out the letter. It does that every once in a while. Like a D. There's a D here now. Whoa. They got an S. There's a, I think they used like an A and a C for the last one. The last problem. So simply having f be declared as function f, right? Which could be this, does not declare that we just copy paste that and this is non-answer. F still has a number, given that it is a variable, because that is how numbers work. That is, you've declared a variable by having it here, having the equal sign, having a letter specifically, because you use letters elsewhere. Therefore, if, for instance, this whole thing was to copy paste this, well, first of all, you got to find the value, right? And second of all, it's meaningless if we, don't have a value. And so therefore, we'll nix that for the time being. We still need to know what T or D means, right? Assuming this in part isn't even there, right? I'm going to assume. It's totally there, but I'm assuming. That means what? Exponent negative T. Since we don't know what T is, we're just going to flip that there for the time being. We already know that it's going to be flipped, so 1 plus 1 to the T. And then I get rid of that. 1 plus 1 to the T. I mean, we really can't solve anything further from there. That's really it. Because we don't know what T is. And neither do we know what it all equals, because we have F equals whatever. So, for F, the function where S equals that. Which, programmer talk says, hey, you need to know what it is. It's just, we're passing it through where S is equal to 1. To which, this is the best we can get. T to the S is equal to, F to the S is equal to T to the S plus 1T. That's it. That's what we got. Therefore, no, that's just a no. Like what else we got? Define a function PR for positive real numbers R and A as this. Oh my goodness. Find the value of S defined as this. Well, I can still have to, figure that out, right? Given that there are absolutely 0 numbers here, baseline numbers, I'm going to assume that it is impossible. Because we cannot find a value when we have no value. We just know it is somewhere between this range. Like, everything here is multiply. Like, exponent, that's an exponent. This is times. This is a 2. Or exponents. They are exponents. Like log R, dr. The only things that could be are D. The D's there. We have just determined R and A. Therefore, it cannot be R or A as our determining baseline numbers. P is our function. The only thing it could be are these D. The D, which is determined toward the start as who knows? We have no idea. So therefore, I deem this as impossible. Hold on, just there we go. Yeah, that there we go. Cool. Okay, on to question 3. So this one is a little more possible than the last one. Let's see. Consider a particle moving on the coordinate plane. Oh my goodness, it's more of these. So we have this, and then the particle. He's a shooting. He's always a solid point. To note the location of the particle at the time, t to which it increases indefinitely. Okay. T in the array of just ever increasing numbers. Understood. That I get. Okay, I get that. By xt and yt. So it goes up this linearly. Okay. I got it. Okay. The initial location of the particle is 0, 0. Okay. It starts there, and it goes linearly up. Ta-da! Look at that. Doing good so far. Also, if x, t, and y, t are equal to a and b. Okay. We don't know a and b yet. It's an if, right? We need to know what an a and b is. So, okay. Then x, then you add them together. Then a plus 1b. Okay, so b stays constant. With probability p, probability, okay. Okay, so that is all that with probability p. The u change. Okay, b changes with probability q. Okay. So probability p, b is the constant. Probability q, a is constant. Then xt plus 1, maybe with probability 1 minus p minus q. Why? Why do you do it that way? Why can't you just say probability, I don't know, b? We already have b, so I don't know, probability r, I guess. Just anything else besides 1 minus p minus q. Here it is assumed that pq, both p, both p and q are greater than 0, and p plus q is less than 1. Okay, because this is okay. I see. It's determining probability as on a 0 to 1 scale, right? So, layman's terms, right? We see it goes here and then here. Just we just add 2 decimal places. Ta-da! So 100%. Ta-da! 0%. Which is always really dumb how they do it that way. Well, it's not really dumb. It's just it's easier for a few things. It's just translate it for us people. All right. Let's see. And the movements of the particle at different points of time are independent. Understood. So far, here's what I got, right? It goes, it always goes linearly, this particle. It goes linearly. But there's a chance that something happens, and it is, and nothing affects how fast it moves. Okay. Time is a constant. Let xy denote the location of the particle such that x was y plus 1 for the first time. Excuse me, that is not how math works. You cannot have a... This is basically saying 1 plus 1 equals 1. 1 plus 1 equals 2, therefore it does not equal 1. Answer the following questions. Show the probability that xy equals 1, 2 as 3pq squared minus pq. Okay. What? Huh? Why are we doing it this way? And by it, I mean what? What does that mean? Why are we 3pq squaring it? Pq squared times what? And that would be what? 3p q is, it's not 6q. Oh, it kind of is 6q, isn't it? So 6q. I'd assume maybe it's not like times though. It is exponent, so I guess it's not. So it's goodness. And then we're using that. There's that, which means it is AB, right? Equals 1, 2, which means we start at 0, right? Yeah, we start at 0, which means it has to proc probability 3 or probability P. I'm sorry, Probability P. Why do they have to make this so tongue-twisty? This is why it's hard, because you need an English degree in order to do the math questions for the entrance exam. Okay. So probability P needs to proc once. Probability Q needs to proc twice. And then the other probability can proc as many times as it feels like. However, I am knowledge checked by this. I don't know what that means. Why are we doing that? I can solve the problem, but this is a determination of this, as we have declared. It is a dumb way of saying it's a variable. uh, um, 1 minus p minus q equals 0, so yeah, it would have to equal 0 because we're going up to the top, I guess. No, it doesn't have to be 0 because therefore this probability wouldn't even exist. So it could be whatever, who knows. Show the probability that okay. So this little 3p cubed squared has to determine what our probability actually is, in percentages. What is p? What is q? We know q is squared to something. In which case, I have no idea. Because we know it's somewhere between 1 and 0. Okay. 1 and 0 on the percentage graph. It could be anywhere. They could both be 1%. They are not, given that this has to occur. I'm assuming it's going to follow the exact probabilities, right? Meaning that in this case, I don't know how we're doing this. Are we doing it like 3p times q squared? Or is it... No, it's probably 3p q squared. That's usually how they do it. At least as I have seen. We do 3, and then it's 3 of these. Which case, q squared means that q squared is twice p squared, right? Or not. Q squared times q squared equals twice p squared. Okay. Therefore, p what? I mean, it could be a few different things, right? Because the other one can proc just about as many times as we like, and no probability thing, right? No, 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 it can't. Right? No, no, it can't. Never mind. Because these move independently of these. We know these always move up in time, but these can stay the same. Or unless this is considered they both move, in which case it's just... No, that wouldn't make sense, because then we can't exact probability that. If, they all, x plus y1 equals a and b. If we move that up, a, b, meaning it have to proc this first time, which means that would have to be 100% if we do exact probability. Which means, how? We can't do exact if we do that. And I'm going to assume we do exact probabilities because that makes no sense otherwise. I got a coin. All right. For demonstration purposes, here is a coin in my hand. You hear it. That's a coin. It has a 50% probability to do heads or tails. And I flip it, and it lands tails, right? I flip it again. It lands tails again. All right. Its exact probability, that would have been heads, but it's not. So therefore, it's, tails. Therefore, you can't, figure that out. You can't figure it out. Because exact probability would tell you, that ain't how that works. So, I don't know. I lost my train of thought there. Either way, it all moves up with probability. Okay. Meaning, yeah, PQ, meaning it's just Q squared equals P times 2. Because I'm assuming we get rid of the 3 there. Well, unless it's just 3, this all equals this. In which case, all those equal up to 1. And that gives us an exact, which is a better answer than nothing. So I might as well choose that. Meaning, if we do it this way, then I'll get a baseline, right? Let's say P is 5, right? Which means that's 10, so what to the second, or what squared equals 10? I don't know. I need to make this easier on myself. We'll assume 4, which means Q is 2. This is also 2, right? This is a baseline, right? You could do 4. 4 there, which means that's 8, and this is, no, we can't do that there, can we? So what is a perfect square? You know, I can do 9 there. It'd be 4.5. We could do 4.5. It is possible, yeah. Do 4.5, right? We need 3 of those added up to 100. In which case, that doesn't work. They both need to be whole. All right. So then I need to remember the next even square in line for me to, have at least a solid chance with this. Meaning, wait, 3 squared, 4 squared is 16. Which means U would be 4. 4 squared is 16. Now this is just not making sense to me here. Okay. I'm overthinking it now. Because I think it'd have to be this part that equals that. And then this is there, and then it's that. But okay. I need to get a solid game plan. Just get it down. Meaning, okay. So this is determining the probability that nothing happens, right? So it's P, Q. Those are solid probabilities, right? So, therefore, 3 PQ that, which means this is that. I say this is that. That's what I say when I don't know what I'm doing. Okay. Which means this equation needs to be true, or up to, I assume 100 or 1. I'll do 100 for ease. This equation needs to be equal to 100 in order, and that needs to be true. Which simply means, Q needs to be, it is Q, right? Yes, Q needs to be twice P while that equation is true. Which is interesting. Okay. Huh. So I'll scratch, I'll not scratch it just for now. So Q needs to be twice P for the equation to be true. So if I do simplicity's sake, Q is 5. No, we'll do Q is 6, which means P is 3. This would be, well, 36 times 3, and that's 9, and then um, over our limit. Okay. Which means I'm not doing 5 because 5 would not equal up because it has a decimal point when you do times 2. So therefore, we do 4, and then 2, and then what? 4 squared is 4 times 4, 16. So, 16, and then you times it by 3. Means this is 6, and this is what? Not enough. So, 6 being too much, I mean, I could look at 5 just for curiosity's sake. 5, 2.5, that would be 25, 7.5, 75. Yeah, no work. Unless this 3 here is just to the P. In which case, we'll go back to 6. So 6, 36, this being 9. Well, that would need to be higher. So we'll do 8, I guess. 8's the next in line, so 8 times 8 is 64. And then 12. So nope there either. What's next in line? 8, 10. 10 times 10 is 100. So huh. Curious. Following it that way, that doesn't work. So it means I'm knowledge checked, right? I can solve it if I know what in the world is trying to say there. But given I have no idea what in the world it's trying to say, makes me think it's illogical. I'll try to transition over to number 2. For non-negative integers n, find the probability that x plus y equals n. For non-negative integers n, find the probability that x plus y equals n. Well, that depends. What are our q's and p's, and like assume we have this graph, right? And assuming it means we're determining the position of the particle over time, right? We're gonna have our median baseline, and it's always going to be at the center, or depending on our QPs, right? And then it's going to have lesser lines out there, right? Because they can. There is a chance it does. If I flip this coin again, there's a chance it lands on heads. Okay, it did land on heads. It lands on heads again, and then it lands on heads again. It did, and then it lands on heads again. That would time it was tails. But there's always a chance it lands on heads 200 times in a row, an infinite amount of times even. In which case, we can't, we don't know. And I suppose that's considering the probability part there. But we don't know the specific QPs, which is kind of determined there as what it wants, but we really can't. I don't think it's possible. And our formula is, of course, going to be different depending on, if it's over there or, right in the smack dab center. So let's see. What's next? For non-negative integers n, let Fn denote the probability that x equals n. Okay. Find F0. That's the one where Captain Falcon's in, right? Okay. Let Fn denote the probability that x equals n. Find F0. I seriously don't know what that means. Like, it's here. It's right there. I found it. Because assuming we're letting f in denote the probability that x equals n, and f0, which means x equals 0, let f... x always starts at 0. It's 100%. What? X starts at 0. That's what it said right here. The initial location of the particle is x equals 0. Yeah. So there's a 100% chance that it's going to equal x0, no matter what it is, because it always starts at x0. What? Express the probability that x greater than or equal to n plus 1, given the condition x greater than n using f0. Express the probability that x is greater than or equal to n plus 1, given the condition that x is greater than n using f0. What? Quite frankly, I have no clue what that means. Express the probability that x is greater than or equal to n using f0. You know, it's going to be 0. What am I missing? What are you not telling me? So, it greater than or equal to, that's 0%, I guess. Because it can't, you got a plus, I assume. Show that fn equals 1 minus f0 to the n f0. What am I missing? The 0, man. It's the 0. What am I missing? So, uh, it doesn't. The it okay. Okay. Almost done. And then I can check my answers that are probably like nothing. Uh, yeah. Okay. Express the expectation. The expectation of x. I expect a lot out of him, man. Using Q and P. What's that mean? Huh? What? Do we expect him to go to lawyer school instead of doctor school? Are we like taking pee samples for our Qs? Like what? What? What do you mean expectation? We already know what all that stuff is. It's up at the top. So just arrow. What? What are you asking? We already know the correlation. So you expect it to do that based on whatever your probabilities are. We don't know the exact probabilities, so therefore we don't know the expectation. Nor do we know what we're expecting at, right? You know, given that x, what is it? The time, the t right there, the t right there. So, yes. The expectation would be different at the time, right? We'll go back to our graph. I'll make a new one. So, we have this. Now, of course, the expectation, assuming it's all 50 probability, right? 50%. The expectation is that it's going to continue on this path. However, it is very likely that it will not continue on the path. It's more similar to a cone shape. That it's going to be likely somewhere in between here. You know, we got our median, whatever. And it still could be out here. But it is most likely in this center line. And even more likely that it's in this cone. So, I expect it somewhere around there. Depending on whatever probability you want. Okay. Express the correlation coefficient between x and y of this. Okay. Using P and Q, where U with a line at the bottom. U, but he has a splint. Crutch. We'll go crutch. U with a crutch. X. Okay. Is equal to EX. denotes the expectation of x, and that denotes the expectation of y. Okay. Um. Huh. So no, no, this is possible. It's just I'm not doing a square root, right? Let me try to break this down as much as I can, though, right? So I'm looking here. Um, assuming E is not anything other than a notifier to notify you uh, of the denotation of the expectation of x, right? And that it does not have any numerical value, even though it really should, because that'd be dumb. We can assume that it's that this part is just going to be uh, the like what ux the squared expectation the square expectation of x times the square expectation of y square rooted and then all that over top of that, which I assume is total probability. So it is the chance. It's just a really complicated chance format. They could have made it simpler, but they didn't. So, yeah. Because these are always going to get unsquare rooted. But it's after the times, so I guess we're timesing them together. I mean, you really can just nix all these stuffs, right? Then it's just that. Assuming the E's don't mean anything besides a notifier. Knowing them, they probably mean something, right? In which case, all these things actually mean something. But assuming they don't, these are useless. So, because we're just doing the same thing. It's like you're timesing it by 2 to divide it by 2. Kind of. Though we are multiplying them together in between, which could do something. It probably does do something. But it's not worthy enough for me to really care. Like, until we get something of note there, I'm not... I mean, it's kind of dumb to say that. But I'm not particularly caring unless we have something to define it with. In which case, then I will just run through the entire thing without any sort of simplifying. All that to say, yeah, they do something in between, so you can't really nix it. Like I said before. I retract my previous statement. In which case, express the correlation coefficient between x and y. I found it. I mean, you can't really subtract anything from there. So, yep. I guess it's answer checking time. So I'll go, check answers, I guess. I mean, it's not like I have any answers, but I'll look at them, and then I will complain. Now, sadly, I was only able to find a solve for problem number 2. I will see if I can get somebody else to check problems number 1 and 3, but they all have no idea, right? So, I expect absolutely nothing out of that. Therefore, let's review what I said for question number 2. I think it's pretty obvious what I said, okay? So, according to something like this, right? Given we do not have enough information to solve it, right? Because we need to know what some of this equals. Let me see here. If I just scrub some of this out, we know it's in a positive number range. We know something about f function. What else do we know? Basically nothing, right? We know s equals 1 in this scenario, given there, right? So, assuming that, here's the solve. It will be linked in the description, the full video. And so I recommend you check it out. Because, goodness, I'm on a rant over this, and I'm sure I'm not going to finish the whole thing. So,
Alright, let's read what the question says. Consider the function fs defined by the following integral for positive real number s. Fs equals integral from 0 to infinity t of s minus 1.
Okay, so I got the range right. He says it's from 0 to infinity, which is good. This is what we want. All right. 0 to infinity. I have assumed properly. We're great.
And based on this, I have to answer the next 5 paths. You may answer without, showing that the above integral converges. Alright. So the first...
Okay. We're doing good so far. I have not failed. Okay? It is 20 seconds into the video, and I have not failed. I'm holding out hope.
Part is to find f of 1. So if I go ahead and plug that in, I'll get t of 1 minus 1. So that's
that. Hold on just a second.
Minus 1. So that's 0.
He has a plug-in. He has something to plug it into. Show me.
E of minus t dt.
What did he do? Well, let's take a look here. So here we have he has changed it from this over here to this over here. We have t to the 0. Don't know how we got that. We have e. There was not an e before. Okay? There is no e ever. He has fabricated an e from absolutely nowhere. Okay? There was exponent. At least I'm pretty sure that's what that means. Hold on, allow me to check. Okay, I've confirmed. EXP here does not mean exponent somehow. It is likely some weird stand-in for Euler's number. Which, once again, does not make any sense here. Why are we putting in a random number? What? It was like 2.7 something or whatever? But also, why? Okay. So even assuming this EXP here, right? EXP is a stand-in for Euler's number, right? How does he get this? Okay, so I guess he translates. I guess it's just pure translation, right? S the 1 is 1 minus 1 0, right? I got that part. I knew that. I didn't get this. It is still exponent, but he does add a Euler, which but that's dumb. Why don't you just do e to that instead of exponent? I'm a programming guy. I see EXP, I think, oh, we're just doing exponents, right? No, but besides that, nothing too out of the ordinary. Carry on.
This integral, and this is a very...
Excuse me? Oh, hold on, back it up just a second, man. Okay, so what are we doing here? All right, so he just so he exits out the T0. What? Huh? Allow me to rant. I'm going to rant. Okay. Mathematical rant with Niro. As I have been told and yelled at by many teachers in the past regarding mathematics, something to the power of 0 is 1. That makes absolutely no sense. And yet, assuming something like this, t to the power of 0 should equal 1 according to those teachers. However, there's no 1. It is equal to 0, as he says in this video. So math is wrong, checkmate teachers, right? That's what we got. Yeah, that's probably right.
And this is a very standard integral.
Oh, really standard, okay.
To this, And with the limits?
What? Okay. So he swaps the side of these here. What? He's like, yeah, it's really standard, really simple stuff. Is this a 2? Did he put in a 2? From where? Okay, range, right? What is this? No, to the negative c. Okay. So you subtract that from both sides. You move it over. Because currently it is empty on that side. I don't. What is this and what? Why is that? What?
You'll get 1. So the first part was straightforward.
Oh, sure. It is 1. That's it. F to the 1 is 1. It is straightforward. Sure. So I kind of got this first part, and then he commits black magic. If you watch Full Metal Alchemist, right? This does not follow those rules. The law of equivalent exchange is broken. Like, it equals. Is that a negative 0 plus 1? Where do we get this? It's like, yeah, he doesn't even bother explaining it because he thinks it's so simple. He seriously adds a. Is that a 2? I'm still. What is this? What did he write? I, what? And he still doesn't even solve this stuff. He knows he only solves this. But if this is a 2, then that doesn't equal. Unless a 2 minus, and then that, which would be a negative, should be plus. 2 plus does not equal 1. Huh? Okay, sir. It's
The
40
second
seconds
part
and you've
says the
committed black
inequality
magic.
e to the power t is greater than t to the power n over n factorial holds for any positive real number t
Okay,
and
yeah.
non-negative integer n. Then I have to prove the following inequality.
Okay, sure,
Okay,
go ahead. Whatever you
so this
say.
equality they gave
Okay.
is integral from 0 to 1. I'll
Yeah.
write this somewhere. Yeah. So they gave us
Oh,
0 to
he
1
needs more
t of
space.
s minus
Okay.
1 e minus t dt.
Okay.
And I have to compare it to
I do
something so
believe
that
I
it.
attempted to solve this one. Hold on. Um, it might be a little hard to see from this. Um, maybe I didn't attempt to solve this one. Maybe it was just toward. No, I think I kind of gave up. I think that's what happened. So let's see what he's got.
The following integral that results to 1 over s. Okay, so notice that e to the power t will lie from 0 to 1 for all t
Okay.
that's in 0 to 1, because if t is 0, then this becomes e to the minus 0, which is 1,
Huh?
and when
What?
that becomes and
So are we using t as the ranges? What? That wasn't possible beforehand because that was 0 to infinity. But now he's doing it here because he what? But we have t. He gets rid of the t, or maybe he's just showing that, and then something else. We have a negative, so clearly he's translated something. I haven't a clue what he's translated because it seems to me he just pumped out a 0 or 1 out of nowhere. We have the only 0, 1 equivalent is this. Or maybe this one, but I don't see where that goes, so what?
when t becomes 1, this is e power minus 1, which is 1 over e, so that's less than 1.
Okay. So it seems here where the first one breaks mathematical law. Okay. The second one is less than 1,
So it's somewhere in
which I,
between
I
0 to
guess is the
1, this e
solution
to the power minus t term.
because it's in
More
the...
precisely, it's in between 1 over e to 1. So the point
Okay, get rid of the... Okay. Just get rid of the whole range thing, why would ya? Nah, 0? No. 0 does not equal 0. 0 equals 1 to the... 1 divided by e, of course. That's how that works.
is that it's always less than 1. So I can, if I write a new integral,
Maybe I
which
just
is
misheard the guy.
ts minus 1, and I replace e to the minus t with 1. So then this integral is always
Or maybe he's just... What?
bigger than the one on the left, because for this whole range of t, this term is bigger than this term. All right, so I get that.
Huh? It just sounds like he's logicking something out, but I don't get what he's logicking out.
And this
Is
is a
this the
very simple
solve?
integral, 0 to 1 ts minus 1 dt. I can use power rule here because I think they have said that yeah, s is positive real number, so I can
Okay.
use the power rule here,
I...
and that will result it into being
What? This is not at all plain to see. Like, look at this. Like, huh? What, what thing is he
this,
doing?
which is 1 over s minus 0. So I get 1 over s. So this integral is less than 1 over s, and that's what I was required to prove. So this part is done.
Huh? What? Huh? Excuse me? Uh, hold on, back it up. You're telling me that somehow whatever is on screen here equivalents to 1 over s. Huh? Hold on. Let me just go back to my own thing, right? I'll bear with the impossible writing here. Okay. So this we'll do this one. This right here, this part specifically equals or is equal to 1 over s. As let me to confirm. Yeah. Now, let's assume, right? The only s in this whole part is right here. Following the law of equivalent exchange, as I'm now calling it, uh, this has to somehow move elsewhere, right? We cannot use the one over here um, because that is our identifier. But if we move this, then it would be something that is not equal or less than. Yeah, it is. This would not be less than this because this does not exist, right? You know, I don't know, if you destroy a diamond, the biggest diamond, then you can't compare it to that anymore because it's gone. You can compare it to records, but you can't you can't do it. Records don't count here, right? Records are like this last problem, right? I can take the A and B here, but that would not be right. So therefore, we have to take it from this little thing right there, which is already minus 1, which uh, I don't even. I quite frankly have no idea. What does he even do here? Like, what is he? He does take it from there, yes. He does take it from that, as we can see via this segment right here. We can see he takes it from here, and then does black magic to get 1 over S. I assume the black magic is this because we removed the T. Why are we removing the T? We are dividing the top by that, which leaves T. That's how that works. T, you can do it in reverse and then get S minus 1 plus 1, which is S. Just in general. We still have the DT. Where is the DT? Where do we move that? What do we do with it?
Over s
He
minus
said
0.
something about a ball thingy.
So I get 1 over s. So this integral is less than 1 over s, and that's what I was required to prove. So this part is done.
I don't think you proved anything, bud.
And the part B says
I,
when n is greater than s and both are greater than 0, show
I'll say I don't have any sort of the knowledge about math that this guy has, but my logic isn't checking out. What's he saying?
that this inequality holds for any real number c greater than 1. Okay. So we have this.
So how's he gonna solve this one? And by that I mean
1 to c
what?
e s
I've
minus
lost him a
1
long time
e
ago.
minus t dt. Okay, now I'll use the truncated Taylor version. E
The
power t,
what now?
that's
What was
e
that?
s minus 1 e minus t dt. Okay, now I'll use the truncated Taylor version. E power t,
I
that's
think you just said
greater
gibberish.
than t to the power n over n factorial.
I couldn't figure
And I
out
say
what he
this
was
is
saying.
truncated Taylor version because you know the Taylor expansion for E, that's simply this, right? So what they've essentially given us is this exact same.
Excuse me? He's like, yeah, you know the expansion for E. It was like, huh? What?
Series, but they've like ignored every other term except the last one. So of course this is bigger.
Huh?
Alright. And now if I go ahead and reciprocate both the sides, then this becomes E minus t less than n factorial over
Are we
t
still
power
counting
n.
E as Euler's?
And this is true for all.
Is this one we count E as Euler's for? Hold on. Where are you? It's this one. We do count E as Euler's. Ah, there's the exponent. You zoom it in. You clear the way and you see, oh, he's hiding over there. Oh my goodness. That's pure knowledge check on that. We have E as Euler's, which is therefore an actual number. And then with that, and then you still can't solve it. What is dt? Is dt something in particular? Because he seems like it is. Huh?
T, all positive t, and t is positive here because they have said 1, because they've given the limits from 1 to c and c is greater than 1. So t is always positive. So this is always true. So if I create a new integral, which is
what? He's making a
this
new
is
thing?
the one that we have.
He's
And
just
this is the one that I'll make 1 to c t s minus 1 n factorial over t to the power n dt.
Okay, look. I'm gonna nitpick real quick. He flipped these around. One should be on top. Okay, that's all.
So this term is always bigger than this term for this given limit.
Yeah, I
So
need
the
my
overall
ego back.
integral is also bigger.
But, huh?
Over t to the power n dt. So this term is always bigger than this term for this given limit. So the overall integral is also bigger.
You know, I just don't think I'm gonna get anything out of this. We're 4 minutes in to the solve. Like, I don't even know what he does for the rest of it. Oh my goodness, it's just more math. Well, duh, what am I thinking? Like, what goes on here? Why do we have so many nesting parentheses? I haven't had that many nesting parentheses since I made my last video game. And that thing was poorly optimized. It was so poorly optimized. It was literally just copy pasting 4 things in a row. You know, if I get into Tokyo U anyway, I think I get expelled.